So far, in the previous videos, we talked about momentum, impulse, and conservation of momentum. To continue our discussion on the topic of impulse and momentum, let's have a couple of examples looking at how conservation of momentum is used to analyze the momentum of the system. Sample problem number 1. A 10-kilogram drum is sliding along a slippery surface at 5 meters per second as shown in the figure. We have a drum sliding along a slippery surface. When we say slippery surface, it's basically considered to be frictionless. Nothing is affecting the motion of the drum, so it's moving along, sliding along the flat surface, the slippery surface, at a constant speed of 5 meters per second. On a ledge, a man is standing 60 kilograms in weight. The man hops on the drum as it passes by under him. Determine the final speed of the man as he rides on the drum. So the man rides on the drum after hopping on the drum. What is the final speed of the man? Mass of the drum is 10 kilograms. Mass of the man is 60 kilograms. The speed of the drum as it slides along the slippery surface is 5 meters per second. Again, frictionless. Nothing is affecting the motion of the drum. So the speed of the drum is constant at 5 meters per second until it reaches the location below the man. The man hops on the drum. Initially, the man is just standing on the ledge, so initial speed of the man is 0. The man hops on the drum and rides the drum as it slides along. So the final speed of the man and the drum is the same. Let that be V final, and that's what the problem is asking for. Now, I mentioned that the surface is frictionless, so the speed of the drum is constant. That's as long as nothing happens to the drum. But as soon as the drum gets under the man hops on the drum. So that affects the motion of the drum. That affects the final speed of the drum. Analyzing the situation using conservation of momentum, we have initial momentum is equal to final momentum. And here we have two objects in the system. That means there are two initial momentum or momenta and two final momenta. Initial momentum of the drum, initial momentum of the man, and then for the final case, we have final momentum of the drum and final momentum of the man. Initial momentum is equal to final momentum. Now, the initial speed of the man is 0. That means the initial velocity of the man, V man, velocity is 0. And the man is riding the drum in the final case. So they have the same final speed. They have the same final velocity, Vf. So we can factor out Vf. We can replace V drum final and V man final by Vf and factor out Vf. So this is our equation. This is a vector equation. To analyze this, we use component method. Looking at the situation, the sliding motion basically is horizontal. So there is no y component. We go directly to the x component. According to the figure, the motion is positive. Therefore, the velocities are positive. So, velocity of the drum, initial, positive direction on the x-axis. And final velocity of the drum and the man. The drum is still sliding along the floor, along the slippery surface. So, positive direction. We are looking for V final. Isolating V final and plotting in the known values, we see that the equation is complete. We are able to calculate the final speed of the man and the drum, 0.714 meters per second. Let's have one more example. Sample problem number 2. A 1 kilogram box slides along a rough horizontal floor. It starts with a speed of 4 meters per second and comes to a stop after sliding for 5 seconds. What is the coefficient of friction between the box and the floor? In the previous problem, the surface was slippery, friction considered to be a frictionless surface. Now we have a rough surface. There is friction between the object and the surface. Since the object is moving, we have kinetic friction. And the problem is asking for coefficient of friction. So basically, coefficient of kinetic friction between the box and the floor. The mass of the box is given 1 kilogram. The initial speed of the box, 4 meters per second. The box comes to a stop. So the final speed of the box is 0 and the elapsed time t is 5 seconds. We are looking for coefficient of kinetic friction mu k. Now, this problem may be solved first using kinematics to get the acceleration of the box. And then you can do force analysis to determine the coefficient of friction. We can also combine force analysis with conservation of momentum to answer the problem. And that's what we'll do here in this example. So first, we do force analysis. You have a box. Say this point represents the box. It has weight. It has mass. Therefore, it has weight. And weight is vertically downwards. The surface is horizontal. Therefore, the normal force it produces is vertical. Say the motion is positive direction, kinetic friction will oppose that. You have horizontal kinetic friction, negative direction. And the box from initial speed 4 meters per second, the box comes to a stop, so the box is decelerating. The acceleration, A, is opposite the direction of the motion, so the acceleration is horizontal negative direction. Since there is acceleration, we set F net to ma, and F net by definition is summation of the forces acting on the system, on the object. So we have weight plus normal force plus kinetic friction. Using component method, we have y component and x component. So y component first, y component of f net y. Y component of a is horizontal, no y component. Weight and normal force are both vertical. Weight is negative direction. Normal force is positive direction. So, minus W plus N. Kinetic friction is horizontal, no Y component. Y component gives us the normal force magnitude is just equal to the weight magnitude. Weight magnitude is given by mg, where g is 9.8 meters per second squared. Knowing the mass of the box, we are able to determine the normal force magnitude to be 9.8 newtons. Going now to the x component of F net is F net x component of A, acceleration, horizontal, negative direction, so minus ma. Weight and normal force are vertical, no x component. Kinetic friction is horizontal, negative direction, so minus F sub k. From the x component, we see that F net y is 0, therefore all the F net x is equal to the F net x. So F net is just equal to negative ma or equal to negative F sub k. Since we're looking for coefficient of kinetic friction, let's use F net is equal to negative F sub k, and we know F sub k to be equal to mu k n. Going now to conservation of momentum. Initial momentum is equal to final momentum. In this instance, we have the presence of an external force that affects the motion of the object. We have an external force that can produce an impulse that will change the momentum of the object, and that is basically kinetic friction. F net is equal to negative Fk. So we use the equation wherein we have impulse. So initial momentum Pi plus impulse due to F net is equal to final momentum P sub F. Momentum initial is mass times velocity initial. F net is constant, so we bring it out of the integration. We are just integrating dt. Integral of dt will give you t. So we have for the impulse, F net times t. And then final momentum P final is just equal to mv final. Final speed is 0, therefore final velocity is 0. So mv initial plus F net t is equal to 0. This is our equation. We use component method to analyze this equation. Y component, looking basically at the situation, the motion is horizontal, therefore initial velocity is horizontal. The friction is horizontal, so F net is horizontal. No Y component. We go to the X component. The motion is horizontal, therefore V initial is horizontal, positive direction, so positive mv initial. F net is basically friction. Friction is heading in the negative direction. So F net is heading in the negative direction, and F net is equal to negative mu kn. So minus mu kn times t equal to 0. Which means mu knt is just equal to mv initial. Isolating mu k is equal to mv initial divided by nt. All the quantities are known. M is 1 kilogram. V initial is 4 meters per second. We have determined the normal force N to be 9.8 newtons and time t is given to be 5 seconds. We are able to calculate the coefficient of kinetic friction mu k to be 0.082. And that's it for now. In the next video, we'll continue our discussion on impulse and momentum. In the next video, we'll talk about collisions. So that's it for now. Thank you for watching.